डियर स्टूडेंट, हमारा ये लेक्चर ऑक्सीडेशन नंबर के बारे में है। ऑक्सीडेशन नंबर को हम डिफाइन कर सकते हैं। इट इज एन apparent चार्ज ऑन एन एटम in a molecule or an ion and may be positive or negative, relating to loss or gain of electrons relative to combined atoms. The total charge on an atom or a molecule would be zero according to the principle when we shall determine the oxidation number of an atom in a compound, and if we have the ion, negative or positive ion, and we want to determine the oxidation number of an atom of an element, then total charge on an ion would be considered as its ionic charge and would be taken as the total charge to calculate the oxidation number of the elements in that ion. Now, taking the example for the determination of the oxidation number of any atom in a compound in an ion, consider KCN, potassium cyanide. The K would always be 1 plus, and the Cn ion would always be 1 minus. As KCN as a whole is neutral, the oxidation number of KCN would be taken as 0. And you can see the total oxidation number has been 0 due to -1 plus 1. Taking the case of MnO2, we can find the oxidation state of manganese. For example, in case of manganese dioxide, oxidation number of oxygen is -2. Oxidation number of MnO2 molecule as a whole would be 0. Then we can find the oxidation number of manganese by adding the oxidation number of manganese with that of oxygen atom. So manganese plus 2 oxygen atom into -2, and you can see manganese plus -4 is equal to 0, and that comes to be Mn is equal to +4. So the oxidation number of manganese in MnO2 would be +1. Taking example of SO2, we want to find the oxidation state of sulfur in SO2 as a whole. Oxidation number of sulfur dioxide molecule will be 0. So taking on left side the oxidation numbers of the atoms, the individual atoms in sulfur dioxide, that is sulfur and oxygen, and taking on the right side oxidation number of sulfur dioxide molecule, that is 0. So we have to find the oxidation number of sulfur, and we can write sulfur here, plus we can add the oxidation state due to oxygen. There are 2 oxygen, and the oxidation number of 1 oxygen is -2. 2 into 2 comes to be -4. And in this way, we calculated here that sulfur's oxidation number is +4. Now, in case of permanganate ion, MnO4 -1, as ionic charge on MnO4 1 minus is its own oxidation number, that is equal to -1. So oxidation number of atoms on the left side and oxidation number of the ion on the right side, that is -1. So we have to find oxidation state, oxidation number of Mn. There are 4 oxygen here, so write in this way: manganese plus 4 into -2, and as a whole should be equal to -1. Then manganese. Here we got -8 is equal to -1. And in this way, we can get the oxidation number of manganese, that is +7 in case of the ion MnO4. Taking another example of the dichromate ion Cr2O7 2-. Here we can see the ionic charge on dichromate ion is 2-, and oxidation number of atoms on the left side, and oxidation number of the ion as well on the right side, that is -2. Here there are 2 atoms of chromium and 7 atoms of oxygen. So we can write in this way: 2Cr O7 should be equal to -2, because the total charge on dichromate is 2-. So we'll write like this: 2 chromium plus 7 into -2 is equal to -2. That's comes to be 2Cr minus 14 is equal to 2 -2. So 2Cr would be equal to +12. Determining for only one Cr, we then will divide +12 by 2 and will get +6. So the oxidation state or oxidation number of the chromium in dichromate ion would be +6. Here are some other examples. You can find out the oxidation state of atoms in the molecules. For example, see here, water. In case of water, there are 2 H +1 +1, and ultimately the oxidation state of oxygen would be 2-. And similarly, here 2- can be balanced by 2+. So there are 2 hydrogen and 1 oxygen. So the total oxidation number of the water molecule, which is neutral, is equal to 0. So 2+ will cancel with 2-. So in this way, we can find the oxidation state of the combining atoms in a molecule or in an ion. Now see the example here: carbon dioxide, oxygen always 2-, this oxygen 2-. So 2-, 2-, 4-, and ultimately carbon would be 4+. So the oxidation number of carbon in carbon dioxide would be 4+. Here see the example of hydrogen peroxide, oxygen, oxygen, hydrogen, and on this side also the hydrogen. So here the oxidation number of oxygen is 1-, 1-, because the oxidation number of hydrogens are 1+, 1+. So 1+, 1+, 2+, 1-, 1-, 2-, and as a whole, the H2O molecule would be neutral, and oxidation state of H2O2 molecule would be 0. In this way, on this principle, we can find out the oxidation number of atoms in a molecule or an ion. Come here, in case of carbon dioxide, oxygen 2-, then ultimately carbon would be 2+. See here, OF2, F always electronegative, as highly electronegative as compared to oxygen. So 1-, 1-, then ultimately in OF2, the oxidation number of oxygen would be 2 plus, contrary to other molecules or ions. So the oxidation number of the chlorine molecule would be 0. Oxidation number of hydrogen molecule would be 0. Oxidation number of any atom, that may be carbon, oxygen, sulfur, when it would be isolated, would always be considered as 0. So here we can see there are 4 oxygen, 1 potassium, 1 manganese. So 4 oxygen mean the total oxidation number is 8 minus the oxidation number of alkali metal, always plus 1, and ultimately the oxidation number of manganese would be 7 plus. Why? Because here we have 8 minus, and on this side that is 7 plus and 1 plus, or 8 plus. So addition of 8 plus to 8 to 8 minus would give us 0, and as your oxidation state, oxidation number of KMnO4 would be equal to 0. So on this principle, we can find out the oxidation number of the different individual atoms in the molecules or in the ion. Thank you very much.